Hi guys, how are you? Hope you're doing great. Okay, let's start our new lesson today, which is lesson 19.4, and we are talking about segment relationships in circles. Prepared by me, Ms. Salma Ahmed. Let's see the contents that we are going to talk about. We are going to have chord-chord product theorem. We are going to have secant-secant product theorem, and we are going to have secant-tangent product theorem. We are going to have the first one, which is chord-chord product theorem and how to apply it. Chord-chord product theorem is saying if two chords intersect inside a circle, then the products of the length of the segments of the chords are equal. So here we have the circle and we have chord AB and chord CD intersect at E. So each chord, it's divided into two segments. So CD, it's divided into CE and ED, and chord AB, it's divided into AE and EB. So the theorem is saying the multiplication of the segments of one chord is equal to the multiplication of segments of the second chord. So let's say it that AE times EB is equals to CE times ED. Let's have some applications on this. Find the value of X and the length of each chord. Here we have the circle and we have two chords. Each chord, it's divided into two segments. Chord CD, it's divided into 6 and 2. And chord AB, it's divided into X and 3. Now I'm going to find X by applying the theorem that we took it from a while, that the product of the segments of one chord is equal to the product of the segments of the second chord. So by applying CE times ED is equals to AE times EB, this is chord-chord product theorem. I'm going to substitute CE, which is 6 times 2, equals X times 3. 6 times 2 equals 12, equals 3 times X equals 3X. By dividing 12 by 3, so X equals 4. Now I'm going to add the segment lengths to find the length of each chord. To get CD, I'm going to add 6 plus 2, so it will be equals 8. And to get AB, I'm going to add X plus 3, which X here is 4, so 4 plus 3 give me 7. Let's have another one. Find the value of X and the length of each chord. Here I have the circle and I have two chords, and it's divided the same into two segments and the other chord into two segments. Now I'm going to find X by applying the chord-chord product theorem, which is HG times GJ equals KG times GI. So this is chord-chord product theorem. I'm going to substitute 9 times 8 equals 6 times X. 9 times 8 equals 72 and equals 6X. By dividing 72 by 6, it gives me X equals 12. After getting the X, I can find the chords by adding the segments to each others. So if I need to get HJ, it will be 9 plus 8, which is equal 17. And if I can get KI, which is 6 plus X, and X here is 12. So I'm going to add 6 plus X, which is 12, equals 18. Another example, given AD equals 12, so here I have, or I know the one chord, which is AD, all of it, it is equals 12. Find the value of X and the length of each chord. So I'm going to apply chord-chord product theorem. AE times ED equals CE times EB. Here I know each segment except ED. How can I get ED? I know that AD, it's known or given by 12. So if I need to find ED, so it will be 12 minus 3 to get me ED. So here what we are going to have, EE, which is 3, AE, which is 3, and ED is the whole segment, the whole chord, which is 12, minus the 3 to get that part, which is 9. So 3 times 9 equal 14x. 27 equal 14x. By dividing 27 by 14, so x approximately equals 1.93. After I get the x, I'm going to add the segments to find the length of each chord. So I'm going to find AD. It will be 12 as it is given at the beginning of the problem. So it will be 12. And CB or BC, yani, it will be 14 plus x, where x is 1.93. So 1.93 plus 14, and it gives me approximately 15.93. The second theorem, secant-secant product theorem, and how to apply it. A secant is any line that intersects a circle at exactly 2 points. A secant segment is part of a secant line with at least 1 point on the circle. An external secant segment is a segment or secant segment that lies in the exterior of the circle with 1 point on the circle. Secant segments drawn from the same point in the exterior of the circle maintain a certain relationship that can be stated as a theorem. So here I have a drawing, and if I have a line which is cutting the circle into 2 points, so I have AE, it's cutting the circle at A and B. So this is called a secant. So AE is called a secant, and the external part is called external secant segment. And the other one, I have a line which have an external endpoint out, and it's cutting the circle at 2 points C and D. So this is called a secant. So this is called, the whole of it, CE is a secant or secant segment, but the part which is outside of the circle is called external secant segment. So here we are, this is called secant or secant segment, and the part which is outside the circle is external secant segment. Let's see, the theorem is saying if 2 secants intersect in the exterior of a circle, then the product of the length of one secant segment and its external segment equals the product of the length of the other secant segment and its external segment. Let's see, if I have this circle and I have 2 secants, so the theorem is saying if I multiply the whole segment or the whole secant AE times the part of the external or its external part, so AE times BE is equal to the other secant, the whole secant times its external, which is DE. Let's say it in another word, AE times BE, which is the external one, equals CE times the external part, which is DE. This is the second theorem. Let's have some applications. Find the value of x and the length of each secant segment. Here I have, it's very clear, this is a secant and this is a secant. So I need to find x first. By finding the x, by applying the theorem, so I'm going to make the theorem, which is the whole secant AC times the external part, which is AB, is equal the whole other secant times its external, which is AD. Let's say it in another word, AC times AB is equal AE times AD. Okay, AC, which is the adding of 5 and x. So I'm going to open a bracket to be 5 plus x. This is AC. Times AB, which is 5, the external part. I'm going to repeat the other. AE, which is 6 plus 6, times its external part, which is 6. Now I'm going to distribute the 5 on that bracket. So it will be 25 plus 5 times x equal 5x equals 6 plus 6, which is 12 times 6. Then 25 plus 5x equals 12 times 6 equals 72. I'm going to take 25 to the other side. So it will be 5x equal 47. By dividing 47 by 5, so x equals 9.4. Now I need to find the secant segments. Add the secant segments to find the length of each secant segment. Okay, now I need to find AC. So it will be 5 plus x, and here x is 9.4. So I'm going to add 5 plus 9.4, it gives me 14.4. Now I need to find the other secant segment, which is AE. 6 plus 6 equals 12. So these are the two secant segments. Another example, find the value of x and the length of each secant segment. So I'm going to apply the same rule to find the x. So SP, which is the whole secant segment, times its external, which is RP, equals UP times TP. So here's the secant-secant product theorem. I'm going to substitute UP, which is 7 plus x. So I'm going to open a bracket, 7 plus x times the outside or the external part of that secant, which is 7. So 7 plus x times 7 equals SP, which is 8 plus 6, times the part which is external out, which is 6. Okay, I'm going to distribute 7 times 7 equals 49, and 7 times x equals 7x, equals 8 plus 6, which is 14, times 6. Then I'm going to multiply 14 times 6, so 49 plus 7x equal 84. I'm going to get 49 to the other part, or the other side, so 7x equals 35. By dividing 35 by 7, x equals 5. Now I'm going to add segments to find the length of each secant segment. So to get UP, it will be 7 plus x, and x here is equals 5. So I'm going to add 7 plus 5, it gives me 12. And I'm going to get the other secant segment, SP, which is 8 plus 6, and it gives me 14. Another example, find the value of x and the length of each secant segment. Here I have a secant and secant, so I'm going to apply the same theorem. So PR times the external part, PQ, is equal PT times the external part, PS. So I'm going to use secant-secant product theorem by applying it and substituting PT, which is 4 plus x, times the external part, which is 4, equal PR, which is 5 plus 5.4, give me 10.4, times the external part, which is 5. I'm going to distribute the 4 inside this bracket, so 4 times 4 equals 16, and 4 times x, 4x, equal, multiply this to get 52. I'm going to take 16 to the other side, so 4x equals 36, so x equals 9. After I get the x, I can find PT, and it's very easy to get PR. So PT is adding 4 plus x, where x is equals 9, so it will be 4 plus 9, give me 13, and PR, which is 5 plus 5.4, it gives me 10.4. Another example, find the value of x and the length of each secant segment. So I'm going to apply, this is a secant and a secant, so I'm going to take the secant-secant product theorem by applying it to get x. I'm going to have NL, which is the whole secant segment, times the external, which is ML, equals HL times JL. So NL times ML equals HL times JL. Then I'm going to substitute NL, which is x plus 5. So I'm going to open a bracket to put x plus 5. This is NL. And times the external part, which is ML, equals 5. So this bracket times 5 equal HL, which is 6 plus 4. This is a bracket, times JL, which is the external part, is 6. I'm going to combine like terms, 2x plus 5 in a bracket times 5 equals 10 times 6. I'm going to distribute the 5 inside this bracket, so it will be 10x plus 25 equals 60. And I'm gonna get 25 to the other side, so it will be 10x equals 35. By dividing 35 by 10, so x equals 3.5. After I getting x, or I got x, I'm going to substitute to get the whole secant, which is NL, and it's very easy to get HL. So NL is x plus 5, and x is equal 3.5, so 3.5 plus 3.5 plus 5 give me 12, and HL, it's very easy to add 4 plus 6, and which is equals 10. The third theorem, secant-tangent product theorem, and how to apply it. A similar theorem applies when both a secant segment and tangent segment are drawn to a circle from the same external point. What is a tangent segment? Is a segment of a tangent line with exactly one endpoint on the circle. Here we are going to have secant-tangent product theorem in the next slide. Secant-tangent product theorem is saying if a secant and a tangent intersect in the exterior of a circle, then the product of the length of the secant segment and its external segment equal the length of the tangent segment squared. So here I have the drawing. This is very clear to be a secant, and this is a tangent. So the theorem is saying that if I multiply the whole secant times its external part is equal to the tangent all squared. So can I say it in another word? AC times BC is equals to CD or DC all squared. This is the third theorem, which is secant-tangent product theorem. Let's apply. Find the value of x. Here I have the drawing, and I have this is a secant and this is a tangent. I'm going to find x only by applying secant-tangent product theorem. So it will be BD times BC is equal AB all squared, or BA all squared. This is the tangent. So I'm going to have BD, which is 2 plus x, in a product, in a bracket, which is 2 plus x times its external part, which is 2, equals 5 squared, which is the tangent. So I'm going to distribute 2 inside the bracket. 2 times 2 equals 4, with 2 times x equals 2x equals 25. I'm going to get the 4 on the other side, so it will be 2x equals 21. By dividing 21 by 2, so x equals 10.5, and that's it. Another real life situation. On a bird watching trip, you travel along a path tangent to a circular pond to a lookout station that faces a hawk's nest. Given the measurements in the drawing on your bird watching map, how far is the nest from the lookout station? So here I have the drawing, and I have, this is the nest, and this is the lookout station. I need to find how far the nest from the lookout station. So I'm going to I'm gonna notice that this is a secant and this is a tangent. So I'm going to apply the third theorem, which is x the whole secant times the external part, which is 25. So x times 25 equal the tangent squared, which is 100 squared. So 25x equals 10,000. By dividing 10,000 divided 25, so x equals 400. So this is the distance between the nest and the lookout station. This is x, which is 400. Another example, find the value of x. I need to find x only. So I noticed that this is a secant and this is a tangent. So I'm going to use the third theorem. AC, the whole secant, times its external part is equals to the tangent squared, secant-tangent product theorem. So AC, which is 6 plus 4, times the external part, which is 4, equal x squared. So 6 plus 4, which is 10 times 4, and equals x squared. So x squared equals 40 by taking square roots for both. So x equals positive or negative 2 root 10. As it's not possible to have the length in a negative sign, so I'm going to neglect the negative sign and take the positive sign, or the positive answer, which is 2 root 10, which is by calculator approximately 6.32. So the x here is 6.32. Thanks a lot, and if you have any question, just contact me. Thank you very much.